Hello, today we will talk about bonding test. Bond strength testing evaluates whether a product possesses adequate strength and is conducted on components featuring micro-bonded welds created by soldering or thin film bonding. This test provides a preliminary indication of the bond's durability and can serve as an indicator for potential improvements when results fall below the critical threshold. We shall now introduce the equipment we possess for bond strength testing. This is RHESCA's bonding tester. The model name is PTR1102, and this single unit can handle everything from wire bonding to die bonding. During microscopic observation, it can perform a series of processes, including position adjustment and measurement, and data transmission. The microscope can be rotated to observe the measurement area from plus or minus 90 degrees. The XYZ theta 4 axes can be operated via a joystick. Measurement is possible using only a printer without a PC connection. The shear test direction is automatically performed according to the shear tool direction. During the shear test, load output is possible simultaneously in the Y-axis and Z-axis directions. We will talk about the types of joint strength tests this equipment can perform. Joint strength tests include pull tests, shear tests, die shear tests, and peel tests. First, we shall introduce the pull test, specifically the one evaluating the loop strength of wire bonding. While observing through a microscope, the hook attached to the load sensor is hooked onto the wire using joystick operation. The hook is raised to break the wire, at which point the load value is measured and the break location observed. Next, we introduce the shear test for evaluating the first ball in wire bonding, or the bumps in flip chip bonding. The tool mounted on the load sensor descends to the substrate surface. The device detects the substrate surface and stops the descent. The tool then ascends to a preset height above the detected substrate surface, presses against the joint, and measures the load value at failure. During measurement, it provides both Y-axis load output and Z-axis load output simultaneously. This enables the force required for failure to be analyzed as a vector. Next, we introduce the die shear test for evaluating die bonding strength. The tool mounted on the load sensor descends to the substrate surface. The device detects the substrate surface and halts the descent. From the detected substrate surface, the tool ascends to a preset height, presses the joint with the tool, and measures the load value at failure. Finally, the peel test is introduced. The wire is inserted with the tweezers open. The tweezers are raised to break the wire, and the load value at that moment is measured. Load output during the shear test is possible in both the Y-axis and Z-axis directions. The following table summarizes the specifications for each test. The maximum load measurement range is 100 kilograms for the shear test. Only the others can measure up to 20 kilograms. The measurement speed range for the shear test is 0.001 to 10 millimeters per second. The others have a measurement speed range of 0.001 to 5 millimeters per second. The drive range differs per axis. The X and Y axes have a range of plus or minus 50 millimeters, while the Z axis can drive up to a maximum of 70 millimeters. Finally, the observation direction. The up-down direction is 45 degrees, and the left-right direction is plus or minus 90 degrees. That concludes our talk about bonding test. At APRO, we conduct a wide range of analyses and tests beyond this specific field. Please feel free to contact us at any time. Thank you.